This is the last of the videos on measurement that we'll be looking at in this part of the unit. Our learning goal here today is to use our knowledge of 2D shapes and their areas to calculate the volume of prisms and use them in a variety of different applications. Now, once again, a lot of the content we're looking at this term you've seen before. We're just going to extend it to more complex situations. So volume is essentially the space or amount inside a 3D object. So how much will it hold? It's always measured in cubic units because it's three-dimensional, just the same as area is two-dimensional. So the basic rule for volume is this: area of the cross-section, sometimes people talk about the base, multiplied by the height. This is the basic rule. So remember we talked about cross-section being if you cut the object parallel to its base, or the shape that's the same in the top and bottom, it stays the same the whole way through. Remember, these are called right prisms because they stand straight up and down perpendicular to the ground. So this is a pentagonal prism. If we cut it parallel to the ground, we get a pentagon as well, exactly the same as the top and the bottom shape. For a rectangular prism, we can use another rule as well to simplify things. So there's a rectangular prism. The parallel base, or the cross section cut through there, is a rectangle. So that rectangle, if we look at it from the top, has a length and a width. So there's our cross-sectional area, length times width, then multiplied by height. So this rule here is one we tend to see a fair bit of, so it's fine to use it. But if you remember nothing else, that basic rule there is all you need. So this is our first example: calculate the volume of the hexagonal prism. So we're given the area of this cross-sectional shape, because we can see if we cut that through here, we get another hexagon. That makes 8 the height. Now, base doesn't always refer to the perpendicular height as standing up and down. It doesn't have to be standing straight up and down. What it is the perpendicular part to the top and bottom faces where they're the same. So if we look at that question there, we've got our basic rule: area of the cross-section times the height. The area of the cross-section, which is shown on the base this time, is 40 square centimetres. The height is 8. So we multiply them together, we get 320 cubic centimetres. Remember, it's cubed because it's a three-dimensional object. The next example is finding the volume of this prism. So this prism has a cross-sectional area of a triangle if we cut it parallel to the same ends. So for the triangle, we've got our height perpendicular to the base of 3, and we've got our base of 4 centimetres. And then we have this big height here of the prism itself, so we could stand it up on its end, like so, to give us our height of 8. Now for these sorts of shapes, my advice is to work out the cross-sectional area first. So in this case, base times height over 2, area of that triangle. Let's move on. So here it is, area of the triangle, base times height over 2. The base is 4, perpendicular height was 3, and we divide that by 2 to get 6 square centimetres. Now remember, this height here is the height of the triangle, not of the prism. Once we've got your cross-sectional area multiplied by its height, there's our cross-sectional area there, bring it down, and multiply by the perpendicular height, which is 8. So we get an answer of 48 cubic centimetres. So now we're going to look at the volume of a cylinder. A cylinder is a circle-based prism. That is, it's got that circle cut through the middle if we cut parallel to the base, same top and bottom. So the area of the circle times height gives us the volume of a cylinder. So the area of a circle is pi r squared multiplied by our height. So there's our entire rule. The other thing we need to know is capacity. So capacity is the amount of liquid or gas, generally, that a container can hold. Units are measured in millilitres, litres, kilolitres, and megalitres. Capital M for mega, little m for milli. L for litres is always the capital. So 1 cubic centimetre equals 1 millilitre, and 1 cubic metre equals 1 kilolitre. These are two facts you have to learn. Now, one of the most common mistakes people make is that because there's 100 centimetres in a metre, 1 meter equals 100 centimeters. They think that 1 milliliter is 1 cubic centimeter, which is a fact we know. Therefore, 1 cubic meter is 100 milliliters, because they use that straight conversion. They've forgotten that this is actually volume. So let's go back and look at that again. Using our knowledge from conversions we talked about right at the start. If we have 1 cubic meter, we know that it's 100 centimeters cubed, because we take that conversion factor and we cube it, which is 1 million centimeters cubed. I apologize for the writing off the end. If we use this conversion here, that's 1 million milliliters. Now, the magic number of 1,000 applies here as well, so if we divide by 1,000, we get 1,000 liters. Divide by another 1,000. We get 1 kiloliter, which means 1,000 liters. So that's the conversion factor there. To change to megaliters, we divide by another 1,000. But this is important. This fact is something we need to remember. It's the most common mistake people make when they convert their units. It's just as easy to learn those two, though. Okay, here's an example. Find the volume of water in litres, so we're actually after capacity this time, of a cylindrical, another name for cylinder water tank. It has a diameter of 5.4 and a height of 3 meters. So our first step here is to draw a diagram. So here's our diameter, right across the circle. There's our height of 3. Now, our rule is volume equals pi r squared times h. We need radius. So first step is divide the radius, or the diameter, by 2 to get the radius. Only halfway across. We substitute in for r and h, and we get 68.7 cubic meters. Now we know that 1 cubic meter equals 1 kiloliter. So we know that this is a straight conversion to kiloliters. Now, there are 1,000 liters in a cubic meter. So to go from here, 1,000 liters in every liter. 1,000 liters in every kiloliter. I've got it right now. So we multiply by 1,000 to make that conversion. Now, as before, there's 3 levels of questions. Beginners, those who don't know the formulas very well or have trouble visualizing things, should be starting with questions 1, 2, 3, 4. Most of us should be starting somewhere in the moderate range, question 5 onwards, where things are a bit more challenging, either with mixed units or multiple shapes or objects. But where we want to be is most or all of us working at those challenge questions. For a real challenge, question 23. It's a nice, tough one. So this is our goal, to be able to do those questions there. That concludes